Today's lesson is about sequences. Now, in this video, you're going to be learning three main things. You're going to be learning the types of sequences, you're going to be learning the sizes of sequences, and you're going to be learning formulas for sequences. I need you to have all of this vocabulary ready when you come into class tomorrow, because we're going to have to be able to communicate using it, okay? So, what is a sequence? It's a pattern involving an ordered arrangement of numbers, geometric figures, letters, or other objects we call terms. All right, so just very basically, you guys know what sequences are. 1, 2, 3, 4, and so on is a sequence. 2, 4, sorry, that's a weird 2, 6, 8, 10, ... that's a sequence. -3, 0, 3, 6, and so on is a sequence. Now, I am not going to draw any geometric figures, but literally we can do this with shapes, and we'll do some of that as we get into the practice. So that's what a sequence is. Each one of these numbers is a term. Okay, the comma is separating the terms in a list of numbers, and we'll see on the geometric shapes what that can look like too. All right, so the first thing we are going to do is we are going to identify our types of sequences. First type is arithmetic, a sequence of terms in which the difference between any two consecutive terms is constant. Capitalized words are the words that I need to be sure you understand what they mean. Arithmetic is just the name of the sequence, and that happens when our terms have a common difference. Now, I say difference, but understand that we can add or subtract, okay? Add or subtract. My pen is not working well. Add or subtract. I'm running out of room. Add or subtract a constant. Just like a linear equation, we are going to have a constant change between each number. Now, consecutive just means that we are going in order from one term to the next in the sequence. Okay? Let's have some examples. 1, 2, 3, 4, 5, and so on is an arithmetic sequence, because what are we adding to 1 to get 2? A 1. 2 to get 3? A 1. 3 to get 4? A 1. Now, sometimes the way we have to find this is by actually starting here at the end and go, okay, 5 minus 4 gives you what? 1. 4 minus 3 gives you what? 1. Okay? So when I have a common difference, I'm going to ask you for D. In this situation, D is a positive 1. Another situation, -3, 0, 3, 6, 9, and so on. So let's start from the end. 9 minus 6 is what? 3. 6 minus 3 is what? 3. 3 minus 0 is what? 3. So if I start at the beginning, -3 plus 3 is 0. So my common difference is 3. Okay, so we may find it going this direction, but when we name D, we're going from the first to the next term. All right, let's go ahead. So arithmetic is when you can add the same number each time. Geometric sequence is a sequence of terms in which the ratio between any two consecutive terms is constant, okay? Ratio is not adding and subtracting, it's multiplying or dividing. Consecutive and constant mean the same thing as they did in arithmetic sequence. So let's look at 2, 10, 50, 250, and so on. So 250 minus 200 gives us 50. 50 minus 200 does not give us 10. So that's how I know this is not arithmetic, because I can't subtract the same number, okay? But 250 divided by 50 is 5, and 50 divided by 10 is 5. So to go from 2 to 10, I can multiply by 5. So here, instead of D, I'm going to say R, my common ratio, is 5. Okay, let's go ahead and look at another one. 24, 12, 6, 3, 1.5. Okay, so let's look at this. 1.5 times what would give me 3? Well, I could multiply by 2. Yeah, 1.5 divided by 3 is not 2, it is 1/2. 3 divided by 6 is 1/2. 6 divided by 12 is 1/2. So from 24 to 12, I need to multiply by 1/2. R equals 1/2. So what to look for here is if our numbers are getting bigger, we're multiplying by a whole number. If our numbers are getting smaller, we're multiplying by a fraction. Okay, so that's a little hint there. All right, so those are our two types of sequences. So now that we know the types, let's look at the sizes. We have two different sizes of sequences. A finite sequence is one that has a fixed number of terms, or it terminates or ends. In other words, 3, 5, 7, 9, 11. Okay, that's 5 terms. That is my entire sequence. It is a finite. An infinite sequence continues forever. It has an infinite number of terms. That's going to be indicated by the infamous ... Okay, it's finite if it doesn't have the dots. It's infinite if it does have the dots. Okay, so now we have an arithmetic and a geometric sequence. Each type of sequence can either be finite or infinite. All right. The last thing we have to do is pay attention to formulas. Okay, there are two different types of formulas. The first one is an explicit. Okay, explicit formula is used for calculating each term of a sequence. Now, both arithmetic and geometric have explicit formulas. So the arithmetic is a of n equals a of 1 plus d times n minus 1. The geometric is a of n equals a of 1 times r raised, this is an exponent, to the n minus 1. Now, this looks really ugly, but we need to get down here and define things. N tells us, it's called an index, just like on radicals. It tells us which term of the sequence we're looking for. So I may want to find a of 6. That little subscript 6 says, find the 6th term. We've already discussed D tells us the common difference. A of 1 is telling us the first term of the sequence. Okay? So over here on geometric explicit, same thing. Our N is still an index and tells us which term we're looking for. We may be looking for the 7th term. R is what we just defined on our definition. It's our common ratio. And again, A of 1 is our first term. So let's see how we can use these. Okay, if I am given the sequence and I want to come up with an explicit formula. Okay, first I need to find my D. Okay, so 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 3, so D equals 3. All right, A of 1, well, it literally is my first term. So A of 1 is 9. So if I want to find a general explicit formula, I'm going to write A of n equals, and then I'm going to fill in my A of 1 plus my D times n minus 1. So if I ever ask you to just write the explicit formula for a sequence, that's what you're going to give me. but I can use this to find a of 6. Let's scoop this up a little bit. 9 plus 3, what was my n? It's that little number right there, 6 minus 1. So 9 plus 18, oh, let's see, nope, let's do 3 times 5. 9 plus 15 is 24. So my sixth term would be 24. Okay? Same thing on the geometric. Okay, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So my r is 3. My a of 1 is 3. So a of n equals, I'm going to do my a of 1 first, which is 3, times my r, but that r has to be raised to the n minus 1. Okay, so let's say I'm looking for the sixth term here. I'm going to do 3 times 3 raised to the 6 minus 1. 3 times 3 raised to the 5th. 3 times 243, which gives me, 729. Sorry, there was no reason to scream there, was there? So I know these were really quick. You're going to get lots of practice in class. The important thing is that you know how to find r and a of 1, and that you understand that this n value is just talking about which term in the sequence. So those are explicit formulas. Then we have recursive formulas. A of n equals a of n minus 1 plus d. And a of n equals a of n minus 1 times r. Now the difference between explicit and recursive formulas is recursive formula is used to generate a new term of the sequence, but it's using the preceding term. What that means is I can't find a of 7 until I know a of 6. I can't find a of 24 until I have figured out a of 23. So the preceding term is the one right before it. Okay? The good news is all of our terminology is the same. N still tells us which index. D is still the difference. A of n is the term we're looking for. A of n minus 1 is the term that comes before a of n, just like I was showing you here. So if we're looking for a of 24, a of n minus 1 is a of 23. Okay, so we're just going to do 2 quick examples. All right, so here D is, I'm going to tell you D is 3 on this sequence. So if I want to find a of 6, I need to find a of 5 first and then add 3. Well, I've got 1, 2, 3, 4 terms. I need my 5th term before I can use this formula. So if I add 18 plus 3, it's 21. So a of 6 is 21 plus 3. A of 6 is 24. So you can see how this isn't quite as convenient as the explicit. Okay, same thing on the geometric. If I want to find a of 6, I need a of the 5th times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So 243 times 3, 729 is a of 6. I know these are really fast. I'm trying to keep this under 15 minutes. We are going to get lots of practice in class tomorrow. Be sure you know your definitions. Okay.